Hello and welcome to another one of these ADD videos. Today we're going to look at a binomial probability problem example. How do I know it's a binomial probability? Well, I know it's a binomial probability because out of 8 classes, I'm asking, let's make that nice and bright, out of 8 classes, I'm asking the probability of a subgroup of those classes given a probability. That's always binomial. Out of n trials, or what is the probability of k successes? That's binomial. So n trials, k successes. So in this case, there's a couple ways you can do this. You can do it either with the table. The table's pretty straightforward. Anytime you want less than a number, you just use the table value. If you want probability of x is greater than a number, or equal to, you do 1 minus probability of x is less than or equal to the number, or minus 1, sorry. This is that whole bit with discrete distribution, because there's no probabilities in between two numbers. Whenever you do the complement, so for instance the probability of x is greater than or equal to 5, that would be 1 minus the probability of x is less than 5. Well, there's no number that has a probability that's less than 5 until we get to 4, so you might as well just change that to less than or equal to 4. That's the concept there. Alright, so in this case we have 3, so it would be 1 minus the function value or the table value of 2 if you did it that way. And you would look up on the binomial table, you would look at the table that had an n of 8. I might have one of those handy. Do I? No, I did at one point. Let's see. It might be here. Let's see. I don't have all my tabs. They seem to have disappeared. Binomial distribution table. Looky there. So if you come over here to 8, the probability was 0.1. You did the function value of 2. You should get 0.9619 right there. And when you do 1 minus that value, you would get 0.0381. Now, if you don't have access to the table, what you have to do is you have to do the formula. So I would suggest doing the complement, because you don't want to have to do probability of at least 3 is greater than or equal to 3. If you don't do the formula, that's going to be 3 plus 4 plus 5. Each one of these has its own calculation. Do you really want to do that? No, you don't. So use the complement. That's 1 minus probability of x is less than 3, which equals 1 minus probability of x is less than or equal to 3, or sorry, 2. You got to go down 1, right, when you go from less than to less than or equal to. So then at that point we would have to do 1 minus probability of what's less than 2. It would be x is equal to 0 plus probability of x equals to 1 plus probability of x equals to 2. So the general formula for this, right over here, n factorial over k factorial times n minus k factorial, and we're going to have p to the k, and then 1 minus p to the k. That's your q is 1 minus p to the minus k. That's a general formula for exactness, so you have to do this formula for all three of those. So 1 minus, usually when it's 0, the number in front is going to be 0, or it's going to be 1. So it would be 8 factorial over 0 factorial. That by definition is 1. I don't know why I switched to orange for the solution. Not that it matters. And that would be 8 factorial. So those cancel. Again, that is 1. And then it would be 0.1 to the all 8. No, actually, sorry. 0.1, this is what happens when you're tired. To the 0 being canceled, right? And then it would be 0.9 to all 8 being canceled. And that would be plus 8 factorial over 1 factorial, 7 factorial. And that would be 0.1 to the 1, 0.9 to the 7. Always 7 plus 1 has to equal all 8. Whatever these two exponents have to add up to the group number. That would be 8 factorial over 1, or 2 factorial now, right? 6 factorial, just like these two have to add up to the numerator. 0.1 to the 2, running out of space. 0.9 to the 6, barely squeezed it in. Close my brackets, even squeeze it. Alright, so let me just show you how to do, where am I? There I am. So the way you would do this, sorry, there's a bunch of work I'm trying to squeeze here. It would be 1 minus, the first one would be 1 times anything to the 0 is 1, 0.9 to the 8. Get your handy dandy calculator out. That's 0.98. Did I do that right? 0.9 to the 8th power. Yeah, I didn't think so. 0.43. And then plus, I'll go off to the side and show you how to do this 8 factorial bit. So if I have 8 factorial over 7 factorial, that's 8 times, and you keep going until you get the thing on the bottom, which that's right away, and the 7 factorials cancel, so you're left with 8 right there, times 0.1 times 0.9 to the 7th. And the last one, let's see if I can squeeze that factorial explanation here. Over here somewhere. So that 8 factorial, 2 factorial, 6 factorial, what I would do is I would go first to the 8 and 6 and try to cancel that. That would be 7. Oh, there's my 6 factorial, so I can stop going down with the factorials. And they cancel. 2 factorial, which is 2 times 1. So that cancels. It leaves me 4 times 7, which is 28. So that leaves me 28 times 1 to the 2nd. And 0.9 to the 6th. So let's see what we get there. 6 equals that. Times 1 times 28. 0.149. And hopefully this hasn't given us something really close to the table value. So if we add all those, we get 0.43. If you get anything greater than 1 here, you know you goofed up. Luckily I did not. I got 1 minus 0.962, which, you do that, gives you negative 0.38. Oops, sorry. A little bit screen there. Or, I mean, positive 0.038. And I believe when we did it with the table, we had 0.0381, which is pretty damn close, if you ask me. Alright, so, yes, if you have access to the table, by all means use it. But how did I know it was binomial? Because out of 8 classes, I wanted probability of a subgroup, 3, 1, at least 1, at most 2, whatever the question is. But out of a group, I wanted case successes. In this case, the success was cancellation of class. Right? I'm sure most of y'all wish that today class was canceled and you didn't have to take your test, but it's not. So what did I do? I used the complement rule, again, using the concept of anytime you want greater than or equal to, you do 1 minus less than that same number, but then when you go to the equal, you got to go down 1 value. So table value, same thing, just look for this table and the appropriate k value. If you don't have the table, you have to use these formulas for binomial probability right here, and you have to do it for each one of these values because all of those are less than or equal to 2. Alright, I hope that has clarified things. Make sure you practice, practice, practice. Thank you and have a nice day.